Welcome to the presentation of the master thesis, Robotic Photogrammetric Underwater Inspection of Hydropower Plants from Manuela Ammann, performed at the University of Applied Sciences and Arts Northwestern Switzerland. With around 57% of domestic electricity production, hydropower is Switzerland's most important domestic source of renewable energy. A major challenge is the high intensity of the plants, resulting in high costs for regular maintenance and inspection of these plants. Current underwater inspections of hydropower plants can be dangerous and expensive, as manual inspections by professional divers are necessary. Photogrammetry and its 3D products are already very common. But new challenges are coming by diving into the water. The light refracts on the water surface, and this leads to different light exposures underwater. The color decreases with depth, and therefore, the image information is also decreasing. And there is turbidity and floating particles in the water, which influences the view. There is various equipment in use. Here you can see the remotely operated vehicle in operation at some test capturing in the indoor swimming pool. The ROV has a payload kit underneath, within the underwater housing, and in it the camera. For some investigation of the calibration of the camera, a calibration frame with Agisoft targets was developed and is equipped with a color chart for color calibration. As a study case, the water lock of the hydropower plant Eglisau is chosen. This lock allows water drainage, which allows the capturing of a reference measurement of the area by a laser scanner and some checkpoints by total station, as you can see here. The calibration frame is mounted in the ladder recess for capturing. With the ROV and the camera, part of the wall got captured for investigations. The use case for underwater inspection is a water filter in the inlet basin of the hydropower plant. No reference measurements can be made, therefore this is only a proof of concept case with visual control. 3 experiments were carried out with the acquisition data. The raw images, then images with a performed white balance to investigate the impact of post-processed images. And the 3rd experiment with raw images but more camera calibration parameter. The resulting point clouds got compared with the reference scan. The deviations shows 78 to 80% of the points in the point cloud over all experiment are within ±1 centimeter. The measurements of 3 lines in the point cloud of the wall and of the reference scan shows a difference of 0.7 centimeters on average over all experiment. Just the attempt with white balanced images shows a smaller resulting point cloud. Therefore, the method 1 with raw images is used for further processing. The use case could be reconstructed successfully and is very dense with up to 0.3 millimeters. In conclusion, objects underwater can be reconstructed successfully depending on the access of the object. If there is a good distribution of the checkpoints, the accuracy of the resulting point cloud is high.